What's up everyone, welcome back. Patrick here. Moving on to the next example. Here we are given a bunch of rational expressions that are multiplying and dividing. We have to simplify them and state the restrictions. So first thing you want to do here is you want to factor everything in all the numerators and denominators. So basically my general steps are I factor, and then before simplifying I get my restrictions, and then after that I simplify, right? Because you don't want to simplify before getting the restrictions because stuff will cancel out, right? And the stuff that cancels, you got to get the restrictions from that as well. So let's go into factoring here. So x squared minus 9, that's going to be a difference of squares. So that's going to be x minus 3, x plus 3. 3x squared minus 10x minus 8. Let's do that on the side. So what two numbers multiply to negative 24, which is the 3 times the negative 8, and add up to the b value of negative 10. So that's going to be what? Negative 12 and 2, right? Negative 12 and 2 works. So if we take 3x squared minus 10x minus 8, decompose that middle term into these two terms that we just found, 3x squared minus 12x plus 2x minus 8, right? Decomposing that middle term into these. So we'll have 3x, x minus 4, and then 2, x minus 4. And then I could take out an x minus 4, basically, and I would be left with the 3x plus 2. Like that, right? So that's what the bottom is going to factor to, right? A lot of times I'll show the work if the a value is something other than 1. If it's 1, then it's fairly easy. When I'm doing this, I'm assuming that you have a good grasp of factoring at this point. So x squared minus 8x plus 16, that's going to be a difference of square, or sorry, a perfect square trinomial, which is x minus 4 squared. And then the x squared. And actually, you know what? Just so it's a little smoother when simplifying, instead of writing x minus 4 squared, I'm going to just write the two factors like that separately. So you could see if stuff cancels out. Sometimes if you just put a 2 and you cancel this and this, right? Sometimes you miss stuff. So let's just put the two factors like that. And then x squared plus 6x plus 9, that's also a perfect square trinomial. X plus 3 squared. But again, I am going to put the two factors like that. And then this final one here, so we're dividing. We could take out a 3 in the numerator. We'll have x minus 3. And then we could take out a what? A 5 in the denominator, and that would be 3x plus 2. Like that. Okay, this is dividing, so we're going to end up flipping this. But again, before we do, let's get the restrictions. So we are on step 2. We factored everything in step 1. Step 2, let's get the restrictions. So what can x not equal? Right, well, notice that x can't be 4. And x can't be negative 2 over 3, right? Because those x values are going to make this denominator equal to 0, right? Basically, the denominators can't be 0. This x plus 3, right? It's the same factor. That means x cannot equal negative 3. That's another restriction. And then from this denominator, it's negative 2 over 3, but we already got it here, right? It's the same factor, so we don't have to write it again. However, you got to remember, if you're dividing by something, whatever you're dividing by, you also get the restriction from the numerator of the thing you're dividing by. Not anything before, but the thing you're dividing by. Because if this numerator is going to be 0, which is basically going to happen at an x value of 3, right? So that's another restriction. If x is 3, we're going to end up having 0 over, what would this be, 11 times 55, right? So that'd be 55, which is going to make this entire thing equal to 0. And then you're going to be dividing by 0 there, and you can't be dividing by 0, right? That's why we're getting the restrictions from the denominators usually, because you're dividing, and you can't be dividing by 0. Well, here, yeah, we get the restriction from the denominator, but we also get it from the numerator because it's going to make this whole thing equal to 0 if the numerator is 0. And then this division symbol means we're dividing by 0, and we can't be doing that, right? So that's why we're getting the restriction from the numerator as well of the thing that we are dividing by. Okay, so that is going to be all the restrictions. So that was one of the tricks here, that one of the restrictions is going to be the positive 3 from the numerator of the rational expression you're dividing by. Now, instead of writing all this out again, if you want, you could write the next line, but what I'm going to do is I'm basically going to just flip this fraction here and change it to multiplying, right? So now we're going to be multiplying. We took out a 5, had the 3x plus 2, and we took out the 3 and had the x minus 3 in the numerator beforehand. So we're just flipping it, changing the sign to multiplication, and then here we can simplify, right? So what's going to cancel out here? Well, notice the x minus 4, that's going to cancel out. I'm noticing the x minus 3 is going to cancel out, the x plus 3, 3x plus 2, 3x plus 2, and then I don't think anything else, right? So we're left with a 5, we're left with the x minus 4, we're left with the 3, we're left with the x plus 3. So 5 times x minus 4, let's keep it factored, 3, and x plus 3. And then nothing here simplifies, right? The 5 over 3 can't simplify. If it can, right, the 5 over 3 fraction, we would simplify that, but it doesn't simplify. So that is your final answer, and then those are your restrictions. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.